It's a first, honest. It's usually, in fact, I've had people claim to take minutes and then run away, and then I never get them and have to go through the audio recording. Yeah, we're not people. So welcome to Bier. We've got a really full agenda. Hopefully, we've been generous in allocating the time slots along the way, so we might have some time for actual comments in the works. Welcome. If you're in the right, if you came for Bier, you're in the right place. Note well, guys, wear a note well. You've seen this in every group meeting this week. It's up online. Take note. So the agenda. Here's a chance to bash and throw at it. We've already had one correction. We had one speaker had to take off and someone's filled in for him, which has been great. I added something at the last minute after dinner with Dino, and I hope you guys are okay with it. It's not in the architecture. It's not really within working group scope, but it kind of shows that an opportunity to think how Bier can be used and different mechanisms that are available out there. So if nothing more, it's a good opportunity to see what other people are thinking about. So anything else on the agenda that looks out of touch, out of hand, needs changing? All right. Once, twice. Quick update. IETF Hackathon was this past weekend. Ice and I were there in hopes of encouraging people to take on Bier in some form at the hackathon. And he put some slides together and presented it out there. We didn't have a good grasp of who was going to be there and what their skills were, so we kind of threw some stuff out and no one bid. And we thought, well, we didn't really think about this in detail. We needed a better, specific case to go after. But Ari brought a colleague of his the next day and from HomeNet. And within 20 minutes to an hour of explaining Bier and how the pieces come together in HomeNet, he goes, I got it. He jumped on this. He did automatic bit assignment. He did a Bier ping app. He did Bier in-cap over v6. And he demonstrated with a 4-router virtual topology, he had to hack the Linux kernel to support Bier forwarding in v6. And he won. Marcus Stenberg, you here? Marcus? There you go. There we go. Thank you. Won the hardcore hackathon. So it's pretty darn exciting to go from, no one wants this to bam, winning. So Marcus, all the kudos to you. It was well done. All right. The charter is now official. We are a working group. One more round of applause. Thanks to everyone who fed back on the charter. A charter is published, but it's also a work in progress, right? So we will hopefully be able to stick to that for a while, but if things come and go from the group, we needed to make changes. That's how the IETF functions. But here are the 8 bulk items that are there. I'm not going to go into detail and read the charter to you. It's online. There's the link. But the fundamental responsibilities of the group are going to be architecture, in-cap, transition mechanisms are on the list, applicability statements, which has to go something to do with taking this from experimental to standards. We have to show how it applies, how we transition, and what the value is in the field, which is the deployment eval at the end. But then use cases is an important part of that, management models, and then IGP extensions, of course, are a fundamental part of Bier working. So any comments about the charter as it sits? I assume everyone's read it and excited, or they're not here. Good enough? All right. So called items. This is great. Right now, the working group has got no items, so we're done. So officially, what we need to do is take it up the list, but I want to get some response in the room, and I'm going to go down just item by item real quick and get kind of a rough consensus of the room itself. So we have the problem statement draft. Can I see show of hands of who's read it? All right, hands up. Keep your hands up to who have read it. Those who think it should be adopted as a working group item, keep your hands up. All right, even more so. All right, hands down. How about those who don't think it should be and we should start over? Excellent. You note that one. All right, taking it to the list. Great. The Bier architecture draft. Who's read it? Excellent. All right, keep your hands up. Those who think it should be a working group adopted item, keep your hands up. The rest of you put your hands down. Look at that, more went up, so we're in the same boat. So let me see that. How many think it should not be adopted? We should start over. All right, great. ARC's pushing along. MPLS Bier and cap. Who's read it? Good. All right. Who thinks it should be adopted as a working group item? Pardon me? So can you take that to the mic so we've got recording? right there.
So at least the naming on the document intends that this is intended for the MPLS working group, and I think DICE actually confirmed that. So it's not the document for here.
Okay.
I don't think I agree with that, Loa. It's not as if it proposes any changes to MPLS. It's really mostly about Bier.
Fine, then ICE has to change the name.
So as precedent, sorry.
I think there's sort of like 2 or 3 questions, right? One is, should it be a working group document in some working group? And then, if so, should that be Bier or MPLS? I think should it be a working group document in some working group, I think is, I think it's sort of like a first question where I think it's pretty easy to answer.
So now, without looking at the charter and going up to specifically, and I reserve the right to be wrong, but our intent in the charter and the text in the charter, from what I recall, was that the work would take place here, and then after we understood and agreed that we would then work with the other working groups that really handle that specific technology and get their feedback on it.
Right, and I mean, if it is a working group item here, we should at least tell MPLS. Now, of course, obviously, 2 of the MPLS chairs are in the room, so I think we sort of noticed that this is happening, and
so
we could send email to the list and just
right. It
make
sounds
sure
like
they
the
know what's
only
happening.
issue was in name only, and if that's because of housekeeping for confusion purposes, I understand completely. If we're just being pedantic, I'm not certain what we should call it. Could you suggest a name that? Fair enough. All right. I want to.
Strictly speaking, just the way that Internet draft names are named, if it's aimed to be a Bier working group document, then just MPLS and Bier in the title would be swapped. Right, because it's the third thing
Fair
on
enough.
individual
We want to
drafts.
sort correctly.
Yeah.
Understand. All right. Yeah.
Ross and Loa, so from your experience, is an informal notification that this work is going on in synchronization enough, or do we need some kind of a formal liaison or something more, solidified?
No, you just need to make sure the MPLS chairs know, which obviously at least 2 of the 3 do, because we're here. I'm sure George knows too. And then we'll need to send an email to the MPL list, but it shouldn't be a big deal.
Thanks. So this came up yesterday in MBOND when I was asking for some feedback, and as the working group had no work items, right? So the plan was go through this process, take it to the list. Once adopted, then we notify these affected groups, and we start distributing our beer. All right. So, but I think anyone don't think this draft should be taken on as a working group item? All right. You had another question? Or another?
I guess.
Yeah, please.
Adding to what Ross said, that we're not picky about communication. Mail between the chairs is fine. We are picky about naming the documents correctly.
Yeah, we got that.
On top of that, I have had an exchange with ICE on this, and we were kind of agreeing that it was an MPLS document. So that's why I raised the point from the beginning.
And I do apologize for that.
All right, so let's get a little bit more formal.
If that had to go for MPLS, but I think Erik is right? There are no MPLS procedures. I think it's fine.
Let's get a little bit more formal. One conversation in the room and name at the mic, please. We have
Nice.
people offline.
You didn't study.
Cisco.
All right. All right, thank you. Next draft. Use cases draft. Who's read it? All right. Of you who's read it, who thinks it should be adopted as a working group item? Excellent. All right. All hands down. Who thinks it should not be adopted and we should start over? Excellent. Moving forward. Thank you. LRE VPN, MVPN, Bier. Who's read the doc? Okay. Who thinks it should be adopted? The author almost put his hand down. That was scary.
Well, I guess none of the best chairs are here, but this is probably a best document because it really is MVPN procedures for the use of for using Bier as a tunnel.
Okay. Thanks. Anyone thinks it should not be adopted? Great. And we didn't have to open any beers yet. We have like consensus so far. This is fantastic. OSPF beer extensions draft. Who's read it? All right. Who thinks it should be adopted?
ICE, Cisco.
Perfect.
This one may actually also need to go down to OCPF working group, right? Because we're adding extensions for OCPF.
So I specifically double and triple checked with Aliyah. It's a draft in this working group, and then we inform them.
Yes. And as I mentioned, that's how we kind of articulated the charter to show that we're going to collaborate. But it's kind of hard to throw requirements to them and expect them to produce something, right? Let's produce something based on our requirements and then confirm with them that it fits within their architecture. Bier IS ranges. Who's read it? All right. Who thinks it should be adopted as a working group item? All right. Hands down. Who thinks it should not be adopted? We're there. All right. And, wow, that was it. We're done. All right.
Well,
Yes.
excuse me, Les Ginsburg. So I'm really curious about the OSPF and ISIS drafts. This seems to be a change in policy. Since you are being blamed, could you explain?
I did feel my ears burning just walking in the room late.
Welcome.
Sorry, Aaliyah Atlas. Yes. So what we decided with the charter was that the ISIS and OSPF drafts would be in Bier with cross working group review, and ISIS will also get to do the working group last call on them as well as in Bier. But it's similar to the CCAMP model where CCAMP was working on things. CCAMP has been empowered to do IGP extensions and make sure that they get cross review. So it could be done here, it could be done there. This way, it's easy to make sure it combines with the architecture and so on. We will make sure that ISIS, and that's part of my chair's role, to make sure that the interactions happen properly with ISIS, and that may be cross presentations and cross discussion on the mailing lists.
So I'm just curious because I'm not aware of a precedent for this. I don't know of any other draft that's been treated this way.
There is a precedent with CCAMP. There are several different ones. I can hunt them down if you'd like. I don't, strangely enough, even I don't have them at the top of my head.
All right.
But I'm happy to show you. I understand your concern. ISIS and OSPF will have a full opportunity to review and comment early and late on the drafts.
I'm not concerned about the integrity of the process. I'm sure I can hold Tony's feet to the fire, but...
You did so before, not only my feet.
It just seems surprising.
Yeah, like I said, there is a precedent, and I'll show you.
All right, interesting. Huh. So your slides are blowing up PowerPoint. That was intentional or otherwise. So I will step them through slide by slide instead of, I try to go to presentation mode and PowerPoint dies. All right, so Eric, you're up. Pardon me? Yeah.
Okay, I was asked us to talk briefly about a few of the changes that have occurred in the encapsulation draft and the architecture draft since we started this process. Next slide, please. A few relatively simple changes to the encapsulation. We decided that the entropy field wasn't big enough and we should make it 20 bits long, so it'll be the same length as the MPLS entropy label, and it simplifies a number of things, essentially when tunneling through non-BFRs. The BFR ID field was originally an optional field, 32 bits long, and now it's a mandatory field, 16 bits long. And one of the benefits of shrinking the BFR ID field is that we free up some bits to use as flags. Let me just say that this encapsulation will probably change several times right before the first time it gets burned into ASICs. And if you decide that you have some great new idea and you need one of these flags, please don't help yourself. Right, make sure it's discussed in the group. And if you were in best this morning, you know why I'm whining about that. Next slide, please.
So Pete, the mic up. Does it make a sound? Okay, good.
There's an issue that was raised just last week about the the first nibble of the encapsulation, which is currently called the version field. This is one of these thorny issues. For all of the first nibble is declared to be a protocol version field. 4 and 6 are reserved to avoid the infamous spurious ECMP treatment that is applied to IPv4 and IPv6 packets while they're in flight. And some people are wondering that given the way the nibble is used in ECMP and other data plane heuristics, maybe it's really not the best place to put a version field, and it might be better to have of a fixed value. The one suggestion has been just put a 5 there, right? And nobody will confuse it with IPv5. And it's kind of a poor man's protocol type. I've also heard suggestions to put 0 there, and then they use 1 for OEM, and it's more like the pseudo-wire stuff. I tend to lean towards the 5 or one of the other kind of unused, one of the other 14 unused IP version numbers instead. Next slide, please. Four modifications to the architecture made in the last few months. Subdomains, automatic tunneling through non-BFRs, deterministic ECMP, and some issues with the bit string length. We'll go through those fairly quickly. Next slide, please. I wish I knew how to turn off the sound on my phone. I should stop soon. One of the issues that a lot of people actually don't understand in the architecture now is the notion of domains and subdomains. The domain, a Bier domain is really the scope of the control plane. For instance, the IGP signaling scope, if your signaling scope for the OSPF LSAs is a network, then your Bier domain is the network. If it's an area, then the Bier domain is the area. The most important Bier parameter that has domain scope is the BFR prefix, which has to be unique per domain. It has the same scope as the control plane. A domain contains one or more subdomains. If the default subdomain is subdomain 0, and a BFR for each subdomain that BFR may have a different BFR ID for each subdomain to which it belongs. The subdomain is the scope of the BFR ID. But what is a subdomain? Well, I mean, it's one of these conceptual things, but one way to think of it is as an assignment of BFR IDs to BFIRs and BFERs, and together with a routing underlay. That is, when you mention a particular subdomain, this is what you mean. You have a particular assignment of BFR IDs, a particular routing underlay, that constitutes a subdomain. Next slide, please. Now, there's been some disagreement about how subdomains are to be treated by the control protocols, but per the architecture document, each BFR has to be provisioned to know the subdomains to which it belongs, and for each of those subdomains, it has to know the routing underlay that belongs to that subdomain, and it has to know its BFR ID, if it has one, in that subdomain. I think by special request, the architecture reserves BFR ID 0 as a reserved value that can be used in the control protocols to mean no BFR ID. According to the architecture, there's no such thing as dynamically joining a subdomain, right? This is supposed to be provisioned, and I know there's some controversy about this. In the MPLS encapsulation, the Bier MPLS label, which is the label on the bottom of the stack of the MPLS stack in the Bier packet, has to be bound to a triple of the subdomain bit string length and the set index. These three quantities need to be inferred from the label. Only when these three quantities are inferred can you actually interpret the bit string. And I just want to emphasize that the bit string length is not part of the subdomain, right? So you could have one label for a particular subdomain, bit string length combination, and another label for a different combination of that same subdomain with a different bit string length. Next slide. Automatic tunneling. I tried to mute myself with colas, and I don't know whether they're going to come out. But one problem that comes up, of course, is as you transition the network to Bier, you have some routers that haven't been transitioned to Bier yet, and then you have some old routers maybe in there somewhere that will never be transitioned to Bier. And can you use Bier at all if you haven't transitioned to every router? And the answer is you can, and it's actually not too hard. In the diagram, the first diagram, the BFRs are in red, and there's a non-BFR in green. And suppose you need to get a packet from A to both D and G. But E says it's not a BFR. It hasn't advertised an MPLS label for the and within the it has not bound and advertised an MPLS label to the subdomain that the packet belongs to. So the way to get the automatic tunneling to work is you kind of change the Bier topology to one of the following two. The first diagram shows that E has kind of faded away, and A is going to, instead of sending Bier packets to E, the packets that were sent to E is going to tunnel directly to F. This second diagram is a simpler but less optimal approach, in which when A encounters a Bier neighbor that when A encounters a next hop on the path to G, which is not Bier capable, it just tunnels all the way to the endpoint. Of course, it's much less optimal to tunnel to the endpoint than to just skip the missing node, but it's easier to find the endpoints because you can figure them out just from the information you have with the packet and the BIF. To figure out the next hop after E takes a little more inspection of the link state database. The tunneling itself can be very simple. It can be as simple as pushing on an MPLS unicast label that's used to get packets from A to F or to G, depending on which you're using. And the same procedure is useful for node protection. That if maybe it is a BFR, but it goes down, you can tunnel right through it very simply. Next slide. Bit string length. There's been some confusion about bit string lengths and when you can use different bit string lengths. What the architecture document now says that BFR has to be provisioned with the bit string length that it's going to use when it imposes the Bier header. And it also has to be configured with the bit string length that it supports as a transit BFR and as an egress BFR. This is not specific to the subdomain, right? The expectation, I think, is that any set of length that it supports, it will support for all subdomains. The BFRs and the BFERs in any domain should support any bit string length that can be originated in that domain. The reason is obvious. You're better off if everybody. If you're going to create packet with a certain bit string length, it's a good idea if everybody supports that bit string length. But it is legal to encounter a BFR that does not support the bit string length in a packet that it receives, and we've added 3 options as to what you can do when you encounter that situation. One is to drop the packet. The other is to modify the bit string length, which probably means making an extra copy of the packet with a smaller bit string length. And then you break up the bit string into 2. And if you do that, you can then send them on in the usual manner. Or you could tunnel through, either skipping the BFR that doesn't support the necessary bit string length, or tunnel through all the way to the end. At the end, it says, well, at the end, the BFR ER has to support any bit string length that will be created. The next slide. I think this is the last slide. This is something that might have been discussed in Hawaii, but I think it's worth reiterating. What we call deterministic ECMP is take a set of ECMP procedures that are described in the architecture that force the path from a particular BFIR to a particular BFER from a particular BFIR to a particular BFER. The path depends only on the unicast routing and on the entropy. If you use deterministic forwarding. If you do not use deterministic forwarding, then the path that's taken from A to B might also depend on what other bits are set in the bit stream. With deterministic forwarding, then what other bits are set doesn't affect the path. And the reason we like the deterministic ECMP is it makes some of the troubleshooting Easier. But suppose you're sending stuff from A to B, and the guy to B complained about intermittent problems. It turns out that these problems only occur when somebody at C decides that he also needs to receive the data stream that's being sent to B. So it looks like an intermittent problem. It's very hard to figure out that the problem only occurs when C is also receiving the data stream. And if you try to find it with a trace route, you might never find it. If you don't know to turn on bit C in the bit string and you do some kind of trace route, you might never actually find the problem because you won't actually trace the path that the packets are traveling. With deterministic ECMP, as long as you can figure out what the entropy was during the period of trouble, you can create trace route packets just by knowing the entropy, which you can usually figure out from just the S comma G. And it doesn't matter what you put in the bit string as long as you have the packets go to BFERP. Is that the last slide? I believe that is. Questions? Comments?
I'm Xiaohu from Huawei. I have two questions. The first is, it seems that the automatic tunneling mechanism would require a separate SPF calculation process, right?
I don't think so.
You need another routing computation instance for BIER forwarding, right?
Can you go back to the tunneling slide? Right, in the more optimal case, right?
The left case.
Yeah, the left case. You would just have to know that the F is the name. You just oh. I gotta figure out how to use this.
Works well. Ooh.
Look, it's remote control for this slide. Yeah, it is. You can get back to that slide?
Yeah, sure. You've got total control. I'll do it for you.
Okay.
Yes.
What we originally proposed was this, right?
Yeah,
And
I understand.
You suggested
I
this.
understand your proposal. My question is, how node A, the packet that's destined for G will traverse F? If
Well, strictly speaking, if you only have to do the OSP at one time, and it gives you the complete set of paths from anybody to anybody. So you can maintain when you're setting up your forwarding structures, right? You can maintain the next hop for each destination and find it pretty easily.
that means the SPF calculation should take the BIER requirement into account, right?
If you wanted to do this, yes. So when you do the SPF calculation, you have to make sure that you save the next
Okay.
hops.
Okay.
If you don't save that,
Yeah. By the way, it seems that this approach is only applicable in the case where link state protocol are used for advertising BIER specific information, right?
My hand.
For example, if if
Well,
BGP
it certainly is applicable if you have link state. Whether it's only applicable if you have link state, I don't necessarily want. This whoever was calling me must be trying calling you now.
Okay.
But I wouldn't say that there's no way to solve this problem in a similar way with vector-based.
okay.
With BGP, we could probably figure out how to solve it. With RIP,
So,
I'm not so sure.
So it's not workable if BGP used for advertising BIER information, right?
Oh, and it's green too.
Yeah.
Yeah, it's an interesting question based on the BGP expense census document that you wrote, whether we could actually figure out what needs to be included in that so that we would know the next hop. Without thinking about it more, I wouldn't say, I guess, that we can or we can't
Okay.
solve this problem.
Okay. The second question is, if I understand the BIER label concept correctly, the label is bound to top of subdomain, bitstream length, and set ID, right?
Right.
That means you would, for a given subdomain and set ID pair, you would require each node to advertise per bitstream length label, right?
It would have to be a different label for each bitstream length.
Okay.
Right.
It seems that the set ID is 10 bit length, in length, right? 10 bit.
So we set ID as well.
The set ID should be 10 bit in length, right? According to your BIER architecture.
10.
Because the minimum length of the bitstream is 64, right? And the total length of a given BFR ID is 16 bit, right?
Yeah, but
Yeah.
as you know, in the bit string, it only takes 1 bit to represent the BFR ID.
So if you want to allocate BIER labels, you would need to consider any combination of set ID and the subdomain IDs, right? And also the bitstream length, possible bitstream length options, right? How many
Right,
bits?
I thought the way I put it was really the most precise way. That's for a given triple, which is the set domain ID, set ID,
Yeah.
and bitstream length. You need to find, it needs to be a label bound to that triple.
Yes, for a given MPS label, there are only 20 bits, right? Set ID is 10 bits. Subdomain is 8 bits. Now the remaining bits
Are you
can
worried
be
that-
used
are you
as
worried there's
only
more than a
2
million?
bits.
Are you worried
Right.
that there's more than 1 million combinations?
Yeah.
I don't think that in an actual deployment, we would have 1 million combinations of subdomain ID, set ID, and bitstream length. Right. Well, like there's only going to be 2, at most 3 bitstream lengths supported in a given deployment. And the number of set IDs is going to be something like 64 or something. And the number of subdomains is going to be what, a half dozen maybe in a large deployment, right? So you multiply this all together, you get a number that's a lot smaller than 1 million.
Okay.
Just to clarify, Cisco, that you only allocate the label for those combinations that are in use, right? You're not pre-allocating the labels for all the combinations, right? So, it's fine. So I got one Cisco comment actually for maybe the working group. So I was explaining Bier to a provider about how the forwarding works, and then to how the set IDs work. And then the first question he asked me was why we didn't call set crates. And I thought it was actually a brilliant name. So make him think about this. Maybe we should change the architecture maybe for crates, because I know you didn't like set initially, but although we haven't been using it now everywhere, but maybe there's something to think about.
Yeah, in our defense, because we've been fairly pedantic about all the little details that we come through here, set came before Bier.
Right.
Otherwise, it would have been natural.
Otherwise,
Great,
we should not have missed that one.
Yeah.
But we have to work in a 6-pack somewhere, I guess.
Six-pack. Yeah, and a crate is normally 24, right?
Yeah.
That's a problem.
Well, yeah, this is a special crate.
Maybe one other thing to think about. So the missing lengths that we defined, right, is in chunks of 64, 120, and 256, right? And 256 seems a good number, I think, for everybody, right? There's a minimum value to support. But maybe it is still good that if you support 256, that you also and backward compatible to support the 128 and 64. So also when we introduce 512, right, that you also support at least 256. So maybe we should think about maybe mandating that, because I don't think it's very complicated to support lower bit string lengths. And also if you have not more than 64 BFERs in a network, you may want to choose to configure it at 64.
So, I mean, are you proposing that if you support a given length, you have to support all the smaller lengths?
Yes. Yeah. Maybe something to think about.
But you wouldn't have to sign a label to each of the small lengths unless you're actually using it in your deployment, so.
Right. Thanks.
All right, anything else? Questions on that? Good conversation, thanks, we have tight time. Next, ICE is up. Which is OSPF, correct? Version 1 update today's. Yours?
Yeah.
All right, let's see if it blows up.
Good. So my name is IJsbrand, ICE from Cisco. So Peter's not here, so I'm presenting this. It was already presented at the BAF in Hawaii, and it's only really a small update to this presentation. So as you all know, we need a mechanism to announce the BFR ID and announce it through the IGP, through the network, right? So the network can set up a forwarding path for that BFR ID. So we use the IGPs for that, right? So OSPF and ISCS. So this document describes the extension to OSPF to announce it, right? So we use an extended prefix LSA to encode that information. So the changes really in version 2 is that we introduced the subdomain, right? As also, as Eric explained, into the encoding, and also moved the bit string length into the MPLS TLV because the bit string length is really a property of the encoding. So basically what we changed is we changed the bitness length for subdomain ID now in this TLV. And this is a hierarchical TLV, by the way, right? So there's a subdomain MTID BFR ID, and then a sub-TLV that describes the encapsulation, right? So currently have one to define the MPS encapsulation. You can see there that, we added the bit string length to this encapsulation. So, yeah, so work in progress, please provide comments if you have them. And, do you know this beer? Bitburger, so for Beat ein Bit, so I think it's quite, Soest is working group, right? Questions?
Xiaohu from Huawei. If you move the bitstream length into the MPS Bier TLV or sub-TLV, that it means it's on this IGP extensions are only applicable to a certain BIR encapsulation, that is MPS BIR encapsulation.
Well, it's a sub-TLV under the main prefix TLV, right? So if you want a new encapsulation, we can define a new sub-TLV in the same place. So you do allow multiple TLVs to be encoded there, right?
Yeah, but the bitstream length, in my understanding, the bitstream length is useful no matter which type of encapsulation is used. Okay.
There might be a disconnection here.
Name, please.
Oh, Jeffrey from Juniper. There might be a disconnection here. I think we agreed to move the bitstream length out of the MPLS sub-TLV. I need to double check, but I think.
Okay, let's take it offline. Yeah.
The second question is, since the bitstream length can be derived from the BIR MPS label, why do you still contain the bitstream length in the BIR handler?
Can you say that again?
Okay. As mentioned by Eric, he said the bitstream length can be determined according to the MPS Bier label.
Yes.
Right. In this case, it seems unnecessary to contain the bitstream length field in the BIR handler.
Well, the bit string length does have to be set by somebody, right? So for a particular encapsulation like MPLS, if you support 256, hello, does it work? So if you add, so someone needs to announce what sort of bit string length you support in a particular encapsulation, right? So for MPLS, for example, you support 256.
Yeah.
In order to announce that to the rest of the world, right, put it into the encoding, right? So everybody knows that what you support. on MPLS. Actually, if you potentially add a different encoding there, it maybe it's a different size that you support, right? So it's really a function of the encoding, of the encapsulation, sorry.
Oh, but my question is related to the MPS BIR encapsulation handler.
So,
Had nothing to do with IGP extensions. Just
Are you asking why the bit string length is both bound to the MPLS label and also appears in
Closer to mic and name, please.
right, Bier header? Right. The expectation that we have, I guess, is that for the processing, right, the bit string length would be inferred from the label, because that's needed to give you a handle on to the BIFT that we use. The reason why there's a bit string length field is why it's in the header is so that a LAN analyzer that sees the packets on the wire will be able to parse the header.
more questions?
Right. So, Eric, failed to do it here. You can take that there. I appreciate that. There we go. Thank you, Eric. So, chair's discretion, we're bumping the agenda around to get the room lively. So if, Andrew, can you jump up the new use cases? I think it should be a little more interactive, I'm hoping. Not that I saw anyone nodding off, because this is exciting, but none of you actually had beer yet today, right? It's your first beer of the day. I'm surprised you're already falling asleep.
Can you flip it higher?
And since my co-chair is handing out, alcoholic beverages, enjoy responsibly.
Here, you can progress your slide. Don't just match all the buttons like Eric did, just one at a time.
Okay, so I'm going to present on the use cases here, filling up for on the last minute here since our original presenter dropped. So between two, okay, clearly this, we've added few use cases and few few co-authors. What's in blue here really shows what we've added, and we're going to go through those quickly. So multicasting layer 3 VPN, we talked about it last time. It's relatively well understood, I think. Obviously, you have a common issue. If you want to be optimal in the delivery, you need to have a SPIMSys. If you need to have a SPIMSys, you need to signal more. If you need, we do have mechanisms to map, to do wildcards, things like that. It all adds control state, adds complexity, adds scale. With Bier, we have an ability to reduce it, which is especially useful if you have a lot of those MVPNs, a lot of C multicast streams. The EVPN, well-established technology almost by now. Definitely a lot of deployments are happening as we speak. One of the issues is how you're going to deliver boom traffic efficiently. Again, the scale kicks in. Yeah, we have this millions of EVIs, and the domain for just EVPN, doesn't necessarily exclude certain EVIs. So if you just go everywhere, you have extremely inefficient. Some initial applications at this lower scale do ingress replication. It's a good solution for a lower scale, but as it puts a lot of pressure on the ingress node to do that replication, and that's a lot of copies. So again, with Bier, because we encode the receiver piece selectively, inclusively in a header, you have a very nice, simple mechanism to decide on a per EVI, per set of EVIs, where you want a specific boom traffic to hit or not. So you get this nice balance between both optimality and scalability. IPTV, I think we presented this on last time, but in a nutshell, a lot of IPTV deployments, every time you add something, you put a static IGMP joint, so you're not relying as much on the receiver joints joining, and you end up with networks when you send all the joints to a source for nothing, because any of the multicast stream really gets to every receiver P as it is. So you have a lot of the signaling overhead there to deliver the multicast streams to PEs. Now with Bier again, because you don't need to build the trees, you have the source driven control. You can very easily control where you get the channels, how you distribute the multicast in the network. Multi-service convergent VPN. So you know, if which one is this? Is one. Okay, so two issues there are. One is the scale again. So there are deployments today that you know, people they deploy, let's say, IPTV networks, lots of PEs for you know, facing the customers. Lots of channels like North America will FTD, lots of channels. So you're ending up with tons and tons of BGP routes for in the network just to provide the connectivity. Now, if you want to utilize this network for something else, keep adding VPNs, you very quickly can grow to millions, tens of millions of BGP routes. Potentially could be an issue, doesn't have to, but potentially it could be. So again, with Bier, we have the ability to deal with this. And then we have this mix of point to multipoint and multipoint to multipoint MVPNs. If you have those in the network, you know, ideally you would have a mix. Ideally you use a point to multipoint, let's say LSPs, where you have your point to multipoint delivery, and you do use multipoint to multipoint when you have the multipoint to multipoint connectivity. The problem with that is that most operators actually tend to really standardize on one technology because they do not want to have two different technologies in the network. It's double operational cost. So they go, you know, if they select point to multipoint, then you know, it is the full mesh. It doesn't help the scale. If they select multipoint to multipoint, then the problem they face is that it's an overkill for point to multipoint, which is generally majority. And problem number two is, as an industry, we actually do not have a wide support of multipoint to multipoint today, either across vendors or across technologies like RSVPTE. You have no solution. So Bier, again, the beauty of the Bier is it doesn't care. The point to multipoint, multipoint to multipoint is the same thing. Inclusive selected is the same thing. So we have a very simple single technology that you need to maintain and understand to deliver any type of a distribution and in an as optimal way as you desire. Control plane simplification. Well, we have the network. Unicast is point-to-point LSPs. Multicast is, let's say, MPLS P instance 6513. Life is good. Everybody is happy. Now, you know, segment routing happened, and some of the operators are talking about removing MPLS control plane and just using segment routing purely without MPLS control plane, just data plane. Well, if that's the way you decide to go, if you have multicast in that network, you haven't simplified everything. You still have to keep your multicast control plane for multicast delivery. So to really achieve the operational simplicity in network like that, you need an answer. And Bier provides you that answer, allowing you to keep the MPLS data path, but remove the control plane, if so desired. And the last use case here is financial service network. I'm going to be struggling slightly here. But many business, the key here is that networks like this, they have many business multicast services. And those business multicast services provide, you know, both types of connectivity, but there's two key. One, you need to have, for some applications, a very optimized latency from source toward the receiver, and not the other way. And the other way is that how we build the trees. And fairness in traffic delivery. You want to be as independent of convergence times and things like this when you restart the service, so you make sure that every customer gets your traffic at the same time. And finally, you want to make sure that you can provide those various business services on a different connectivity graphs. And because you have those different applications, and sometimes you may want to go one path, sometimes you may want to go the other path. So to start implementing that on a network, the only tools you have are really, MPLS, cost links, IGP tools. If you have many of those services, you're very quickly getting very complex, because you touch a cost here and it has an impact on everything. So they're looking at some form of isolation of business service to deliver the requirements with the flexibility they have. And because Bier provides you this control from the source and potential control with the external devices, they see this as an opportunity to improve on the architectures they have today. And I hope
We're fine. We're fine. We got plenty of time for discussion.
Have you considered internet? Lenny Juniper. Have you considered internet multicast as a use case?
Not myself. I don't think any of others, but if we're happy to get other use cases. The general stuff, like the use cases are very interesting. A lot of stuff is not broken there today. It's when you start to moving it to the higher scale or require higher flexibility, that's where the Bier really kicks in. And so what we try to point here in the use cases we have is that, yeah, you can in a lower scale, on an existing scale, maybe deliver the services, but as you start going over those, you may need different alternative and potentially more simple solutions. So
yeah, the reason I pointed out is the real benefit, it seems, of Bier is you eliminate per flow state, and the place where that could be needed the most is internet multicast. Maybe not yet, but
Where in the network? This is Greg. Internet's a big world, right? Yeah. So each network has a different consideration in terms of flow, state, control. Right. So if you're using MVPN to transit internet multicast service, then that would be a case that covers a portion of it from that provider's perspective. Right. But if we're going to go in, and I agree with you, I mean, great to see that, but maybe we need to break up those elements, from DC to desktop and see how it would apply.
Sure, yeah, and how it might apply to, interacting with AMT, but it seems like some of the use cases are where state is the least of the problems, and don't want to polish the shiniest apple. Where this could be beneficial could be in other places where state could be a huge problem, and I think interdomain internet multicast would be one of them.
We welcome your co-authorship and input into the document. If you have a new use case, please provide it.
Yeah, absolutely. Like all the use cases that we have kind of in the document are really driven by, bunch of us, each of us kind of contribute to their own use cases from real networks, from real problems. So, happy to add more.
This is Dino. Have you considered connecting Bier domains together with existing overlay solutions? So if you want faster deployment of BFRs and they're not directly connected, use overlays to make them directly connected.
I don't think this is spelled out, but definitely, how you connect Bier to anything that's there today, and how you stitch things, or how you deal with potential Bier scales, I think that's already being talked on. I'm not sure necessarily we want to keep adding.
It could be part of the solution. It could be a specific solution as part of the transition use case.
Do you want to answer that? Yeah. Go ahead, do that. From Cisco. So Eric actually presented a little bit of that in the architecture draft, right? They can actually tunnel through routes that don't support Bier. It's sort of a transit, similar to transit case.
Hi, Tom O'Keefe, Verizon. I'm involved in multicasting financial market data and trading transactions. And there's another requirement for financials, and that is the ability to do physical diversity between redundant feeds. For example, the market vendors publish an A feed and out of a different location a B feed. And typically they want the A feed on the best latency path, but then they want the B feed on a physically diverse path so that they can receive, one or the other in the event of a failure.
Yeah, I agree. I think we kind of try to squeeze this into the 10 minutes. So, and that falls into this topic of, multiple services need to have a very good control how the streams are delivered, and the redundancy and making sure that it's fully redundant, totally different paths are taken. It's one of those cases.
Right, and I'm looking forward to reading the new traffic engineering draft as well, which has just recently come out and I haven't read yet.
So the subdomains, I mean, multi-topology, if you have the luxury of implementation, but otherwise the subdomain will address this kind of stuff, right? I mean, the service separation, sorry? Yeah, Tony. So basically, services run on top of Bier. The subdomain allows you to provide separation, be it in terms of quality of service, of the topology transverse, any kind of business policy that basically forces you to shape the topology, traffic engineer the topology. So I think we do have a tool for it if you look at the details.
I thought that with Bier, you don't really need redundancy. Jeffrey Zhang, Juniper. You don't really need the redundancy paths anymore on the multicast side. You put the packet into the network with the bits indicating the destinations, then you will get to the BFERs, finding whatever path it is there available for unicast.
Yeah, but what he's talking about is you have a source out of one of the BFIRs and a source out of another one, and when you deliver that, you have a total geo-redundancy when you go one way and the other way. You do have two streams, and you want to make sure that no failure in the network ever causes you a failure of both streams.
But if you have two feeds, then both feeds will follow their own path, get to the egress, and then egress will have to pick which feed to use.
Not by default, unless you do something with unicast. There's nothing preventing two of them to go through some single node or single link through unicast routing. So you actually have to do something. You may need to do something extra to provide the full differentiations of path.
Okay, we can talk offline.
Tom O'Keefe, Verizon. The market data, it's the same application data, a stock trade or something like that. But out of one site, it's one S, G, and out of the other site, it's a different S, G. So it's actually two separate streams. So both streams are delivered to the customer's host.
Okay.
Very good.
Thank you, guys.
And your beer. All right. Next up is Tony. See if I can exit this with some sort of sanity. All right. These cases is gone. You get to shine into my eye.
You wear protective lens?
Which one's first?
Not the automatic. It's just a phone.
This one.
So is Eric Northmark still in the room? I think he left. So I sent out an email that there was a presentation yesterday in the routing working group, which targets us specifically as well about the. Do I have to shake?
Yeah, absolutely.
Seriously. So there was the AD scheduled, whatever that was called, the design team that was looking specifically at data encapsulation requirements. Because there's a bunch of those coming up, and we are one of the suspects. So it's very good material, and Eric presented it yesterday, and I hoped he'll present it here, but I think he left meanwhile. So I highly recommend to read it up for everyone here who has ambitions towards encapsulations. I've been around, but I learned a lot, from listening to Eric. Good. Does it work?
Oh,
See, it doesn't work for me.
Try that.
Broken. So, type.
Did that work? No, you're just stopping it. Previous one there.
Yeah.
Um,
First one. No,
The title.
yeah. So it's just the update on the ISI support for Bier. A lot of comments. Architecture draft was clarified, so that had a couple of implications. And there is one idea for which Les is probably already keeping his irons hot for me. Next one, please. All right. So the subdomains have been very much clarified on the architecture, and we already see, like what Tom is talking is specifically this. That reflected into the ISIS draft. So the subdomains are mapping to a multi-topology. All right. All routers must agree on which multi-topology the subdomain matches to. Subdomains have a single encapsulation architecturally. So if we have multiple encapsulation within a subdomain, we cannot translate. So far, it is not. I don't think it's spelled out, but the implications is we do not encapsulation translation. Subdomain has a single tree or forwarding strategy type. And what we have in ISIS draft is now that any router that does not advertise enough labels to cover all the BFERs in the subdomain will be ignored for computation, because we may generate holes where a router doesn't have the label to forward a set. Okay. So what we have right now is, I'm not going to packet formats, is that each router advertises the subdomains, and under it, the label according label ranges, and optionally a tree type. Now, it is suggested not to advertise any TLV for the tree type and interpret it as SPF. But that will leave us a way forward to advertise different ones, and routers who do not support them to understand that they cannot participate because the tree type changed. Today we don't advertise anything, and it is not clear what it means. So future routers may see a tree type and not understand it's a tree type and just happily forward along SPF. Next one. And the other is more IGP internal suggestion that we put on the Bier sub-TLD a version number with a backwards compatibility bit. So that will allow us to add new sub-TLDs to an existing packet format, and at a certain point in time tell routers who do not support it to not participate anymore. That specific application which will be showing up next, is that we can deploy Bier as it is today, and then seamlessly with the old routers plug in an extension which will allow for automatic bit assignment for the BFERs. In case that there are enough subdomains, that there is enough BFERs, that manual assignment will become problematic. That's pretty much the whole update. I think I flipped through the next one, and then take comments. That's the next presentation already. So I'm not showing here all the gory details of bits and packets formats. I think that's an ISI's working group presentation, where people will go after the bits.
Today.
So the next presentation is basically, that's a separate draft, which suggestion an optional addition where automatic BFER, bit mask assignment, can be performed in the network.
It's not coming up. Am I losing it? All right, I gotta find this thing. I can actually see this page. Okay. Yeah, I know. So I can see more of my screen, kind of where the document went. Sweet. not opening. How could that be the case? Assignments, no. That's just, it's not opening.
All right.
Something toast
So
with that
I just do it from memory. So since we can run pretty large number of BFRs and BFERs possibly, and we have the concept of a subdomain, and the BFR ID is subdomain specific, at certain point in time we may face the problem of automatic assignments of the bits, because when the bits collide, we have a misconfiguration problem in the network, and we may lose parts of the traffic. They won't be delivered. So the suggestion is that it's an optional extension on top of the existing Bier routers, which can be assigned the values automatically or via an SDM controller, whatever, that an extension can be implemented where a Bier subdomain elects something which is equivalent to a designated router and a backup designated routers, which will respond to requests for bit mask assignment, kind of like DHCP. And those assignments can be advertised within the existing TLD, so the old style router see those assignments and cannot distinguish them from manual assignments. All right. Now, as always, it's a distributed solution, so it will give very high resiliency for the coding complexity versus a centralized solution, which will be simpler, but has a single point of failure, and in terms of replication, generates its own complexities. So that's pretty much the gist of it, and the rest are highly IGP-specific bits and discussions, especially the backwards compatibility, which is kind of a new suggestion. It's not the way it has been done before on IGPs. And that's pretty much the gist of the whole thing. So if you're interested in the gory details and the ensuing grilling that I'll get, you're welcome to the ISI's working group. Otherwise, I'll take the comments now.
Hi, Cisco. So I see we had a discussion before, right, on over email. I see the BFR ID as something more like static and as in sort of an IP address and identifier that you give to the egress router, right? And nothing prevents you from applying different services on top of that, right, with subdomains and so on. So I think you should treat it as like an IP address that you configure. Now, I don't think that, let's say, if you want to do that centralized, it's probably more logical that people will use like an SDN controller or how they configure their network today, right, from a central place. So having a dynamic mechanism in the network to give you unique identifiers dynamically, of concerns that actually that dynamicity is not used, and also just adds unnecessary complexity to the network.
It adds complexity. I mean, that could speak against DHCP, right?
Well, but
things are small. Everyone was perfectly happy to do the EF config. At certain point in time, you need a DHCP. So this is an optional complexity that can be switched on if necessary.
Right. But I don't think DHCP is a good example, because that's really on the edge of the network, connecting to hosts that dynamically come and go, right? I don't think that applies to the core of the network normally, right? But maybe it would help if you give an example where the dynamic BFR IDs are really used. Right? That would be better.
It applies only to the BFERs, right? Because the guys in the middle have no IDs. Otherwise, you'll be running out of them.
Maybe it's good to have an example when this will be a problem, when a good use case for dynamically assigning the BFR IDs.
If you have a large administrative domain, right, and people bring up services for customers and have to provision those things, you have a possibility for misconfiguration if you have multiple administrators putting those values on. I mean, it can be argued that you do L3 VPNs, you have the same problem, and somehow the route targets work out. So it may be the case here as well.
But a BFR ID is only applicable to the router itself, not to the service, right? You can have 100 VPNs, right? But that route only needs at one time a BFR ID. Right, so it's not necessarily something that you hand out on a per service basis.
It is per subdomain.
It's per subdomain. Yes.
Per subdomain, yes.
Yeah.
So it depends
but
how
not
many.
Per service.
Sorry?
It's not per customer service.
No, it is per subdomain. And how you map onto subdomain is again a matter of choice, right? So the question is, will it grow big enough and will people care about having it automatic? So will they pay the complexity to lower the possibility for misconfiguration? And I do not have an answer for it.
But just to point out, the architecture draft mentions, right, if there's a misconfiguration, you can detect it, right, and you prune them out.
Yes. Yes, so that's important. Yes, this is not so you can detect misconfiguration. Misconfigurations we can detect, all right? So it is an optional complexity to lower, to possibly scale things higher when a certain dynamicity is required. Whether it is really required, the deployments will show, okay? But again, it is fully optional. I try not to sink it in the original proposal because if you do not need complexity, you don't want to run this thing. Yes.
Xiaohu from Huawei. I have a question about the rationale of the subdomain concept. It said the subdomain is mapped to a given topology, right?
Yes,
Yes,
it is tied.
yes.
It is
Somebody
tied
had
to
told
a
me.
multi-topology. You cannot run a subdomain distributed over multiple multi-topologies.
Yes,
No.
yes. Somebody had told me the subdomain can be looked at Pullman's multi-topology routing approach, right?
Poor man's in the sense that you do not control the topology.
Yeah.
You control where the subdomain is visible, but you do not have a good control over the topology that it's using, which multi-topology gives you, right? The multi-topology lets you prune the topology you need to run what you run. Subdomain just allows you separation in different dimensions. You get different labels, but it does not mean that you get different links.
Yeah.
Okay.
So I'm wondering whether the working group will consider rich man's multi-topology routing later, or the Bier is only dedicated to poor man.
No, I mean currently we have both. If we have the information distributed at control plane architecture resolution, we have the multi-topology and we have the subdomain.
Yeah.
Right? If your IGP implementation supports multi-topology, which is a high requirement, you are perfectly free to use it. And you can actually run a single subdomain.
Okay.
The mapping is arbitrary, so I don't understand what a rich man multi-topology would be.
Yes. In my understanding, one possible usage of the MT routing is fast failover. For example, the packet can be switched from one topology to another upon failure. These two topologies are disjoint. Do you agree this?
You're teaching me new stuff. I came up with this stuff, but I never saw anyone trying to use it this way, but I'm listening. I never saw it being used for failover. I saw it being used specifically for the topology disjointness because of business policies, or sometimes for the simple reason people deployed multicast and they were scared of multicast, so they wanted it on a very well specified piece of their network that didn't matter that much. But I never saw it used for like failover resiliency. That I never saw it being used for.
Okay, let's forget about that. Another possible usage of the MT routing is for a given MVPN group. In order to make all BFER for a packet to be assigned the BFR ID as densely as possible, you can assign them a particular subdomain, right?
Yes, but subdomain will do it with multi-topology is not necessary.
For the traffic within that VPN instance, if I want to use different topology for different traffic type, you need to allocate different subdomains for different traffic types.
Yes, because if you have different requirements on a set of packets, you are in reality running a different service, right?
Yes.
So the subdomain ID serves also this purpose, to give you what I, in widest terms, a service separation. Whether your separation is temporal, spatial, in terms of quality of service, any kind of SLA you are selling at a premium, that's what this thing is for. So you can come up with tons of examples why you want a separation and are willing to pay for it. And the MT and the subdomain ID gives you the two tools of resolution. Subdomain ID is much lighter. MT is a pretty heavy hammer, and you need expensive gear that supports it, because it's not easy.